In this video, I'm going to work through the exercise we have here, in which we're given the vector equations of two lines in 3D space, and we need to determine whether those two lines intersect, coincide, are parallel, or whether they are skew. Now, as you can see from the title here, the two lines that we're going to be dealing with here are skew lines, and so really the purpose of this video is for you to learn how to recognize when you're indeed dealing with skew lines. So let's get started. I'll just write SOL as in solution. To answer this type of question, our approach is to look for a point of intersection. And for that, the first thing to do is to rewrite both of these line equations in their parametric form. And so I'll start with that. So I'll just say for line 1, the parametric equations would be x equals to negative 2 plus 1 alpha. So I'll just say x equals to negative 2 plus alpha. We'll then have y equals to negative 1 plus 1 times alpha. So y equals to negative 1 plus alpha. And finally, z equals to 3 plus 1 times alpha. So that's z equals to 3 plus alpha. Those are the parametric equations of the first line. I do the same for the second line, so line 2. Here we have x equals to 8 plus negative 2 times beta. So that becomes x equals to 8 minus 2 beta. We then have y equals to negative 6 plus 3 beta. That's y equals to negative 6 plus 3 beta. And finally, z equals to negative 11 plus 5 beta. And I'll write that there. That's z equals to negative 11 plus 5 beta. Okay, we now have the parametric equations of the two lines. Step 2, we equate each of the corresponding right-hand sides we have for each of the variables x, y, and z. In other words, we're going to equate negative 2 plus alpha with 8 minus 2 beta, as well as negative 1 plus alpha with negative 6 plus 3 beta, and finally we'll equate 3 plus alpha with negative 11 plus 5 beta. So let's see, we have negative 2 plus alpha equals to 8 minus 2 beta. We then have negative 1 plus alpha, which equals to negative 6 plus 3 beta. And finally, we have 3 plus alpha, which equals to negative 11 plus 5 beta. And so we see here that we now have three equations with two unknowns, which are alpha and beta. And to finish this second step properly, I like to rearrange these three equations, making sure that alpha and beta are both on the left-hand side, and any constant term is on the right-hand side of each of these three equations. And by all means check, but in doing so, I find that the first equation turns into alpha plus 2 beta equals to 10. The second equation turns into alpha minus 3 beta equals to negative 5, and the third equation turns into alpha minus 5 beta equals to negative 14. There we go. Now that's done, we move on to step 3. And in step 3, we choose any two of these three equations and solve for alpha and beta. I'll go ahead and choose the first two equations, so this one and this one, but you could choose absolutely any two of the three that you see here. Now if I quickly copy those two equations, so I have alpha plus 2 beta equals to 10, and alpha minus 3 beta equals to negative 5. Solving these two equations simultaneously, I'll call this top equation equation 1 and the bottom one equation 2. And I see right away that if I were to subtract equation 2 from equation 1, then the alphas would cancel each other out. In other words, I'd eliminate alpha. So let's do that, and I'll just write it. I'll find E1, so equation 1 minus equation 2. So that becomes alpha minus alpha, which is 0, so I don't have to write anything, and 2 beta minus negative 3 beta, which turns into 5 beta, and that's equal to 10 minus negative 5, which turns into 15. Now dividing both sides of this equation by 5, we quickly find that beta equals to 3. And I'll go ahead and box that result. Beta equals to 3. Now that I found a value for beta, I use either one of the two equations I just used to find alpha. And I'll go ahead and use equation 1 here and replace the beta I see by 3. And so I'll just write equation 1, E1, turns into alpha plus 2 beta, so that's 2 times 3, equals to 10, which leads to alpha plus 6 equals to 10, and so alpha equals to 4. There we go. Now at this stage, the end of step 3, we've found a value for both alpha and beta. What that tells us is that the two lines that we're dealing with here either intersect or are skew. To determine which of the two it is, we move on to the fourth and final step. And in this step, we turn to the equation we didn't use earlier on. And in fact, I'll box that equation. That's this one here. There we go. So that's alpha minus 5 beta equals to negative 14. And the idea is to replace both alpha and beta by the values we just found. So if I do that here, we have alpha equals to 4 and beta equals to 3. So this turns into 4 minus 5 times 3 equals to negative 14. And if we actually calculate this left-hand side, this quickly turns into 4 minus 15 equals to negative 14, and that turns into negative 11 equals to negative 14. And now, the fact that negative 11 is not equal to negative 14 is exactly what tells us that the two lines are skew. In other words, these two lines do not intersect. And it's definitely worth making a note of the fact that throughout the first 3 steps of our working, it appears as though these two lines intersect. It's the fourth and final step we have here which shows a mathematical inconsistency which tells us that the lines are in fact skew. And if you're unsure of what skew really means or what it looks like, let me try and illustrate that for you. Now in the upper right hand corner, I'll quickly draw an x, y, and z axes. So I'll have x here, I'll have y right here, and I'll have z pointing upwards. And let's say I draw a box whose edges run parallel to the x, y, and z axes. That's just to make my life easier to draw it. So something like this. There we go. Skew lines are lines that are not parallel and don't lie in the same plane. And one relatively simple way to visualize that is to look at the lines that form the edges of the box I've just drawn. So I could say this edge here, there we go, and this top edge right here, like so. It's quite clear that these two lines don't lie in the same plane. Indeed, the green line would be in the plane at the top of the box, and the pink line would be on the plane at the bottom of the box. And it's also quite clear that these lines will never intersect. Nevertheless, if we were to look at this illustration from above, so looking down the z-axis, and I could try and illustrate that there, I'd have my x-axis going downwards and my y-axis going here, and so my z-axis would be pointing out of your screen with the box here. Then from above, we'd see something like this. We'd have our pink line here and the green line doing this. And it would appear as though these two lines intersect. And that's why at the end of step 3, we do in fact find the value for alpha and for beta. Step 4 is what tells us that these two non-parallel lines in fact lie in different planes and are therefore skew. And there we have it. That's it for this tutorial.